Hello everyone, welcome to this video series where we talk about various tools, Python tools which we use for data science and machine learning. And in this series we are going to talk about the NumPy arrays, or also called numeric Python. As you can see in your screen, NumPy arrays are the backbone of machine learning and data science in Python programming, and it's imperative that you must know about it. Okay, so let's go ahead, try to understand how to use NumPy arrays. You can do pip install for NumPy array, or if you are using Anaconda Navigator, you can do conda install. Okay, so let's go ahead and start using NumPy. First, before using NumPy, you need to import NumPy, and I do import by calling import NumPy as np. Now, why np? You can write any name over here, but np is kind of de facto thing, and in your code, if somebody sees np, they don't need to go in the top of your file or some other place to understand what np means. It is a de facto way to refer to NumPy. So use np for better understanding of the code. Now, data science and machine learning is all about number, which means we have to create arrays of numbers. And how we can create that? We can create by calling a function in NumPy called array. So to create a array of numbers, or in fact array of anything, we will see that in a moment, we will call a function called array. So we will call that function and we will pass inside something similar to Python list, and we will get our NumPy array, and you can see that NumPy array is created with array of 5 element. Now look wise, it's extremely similar to Python list. Okay, so if I create a Python list like this, and this is how Python list looks like. It is extremely similar at this moment of time. So the question comes to everyone's mind, how NumPy is different from Python list, and why should I use NumPy and not Python list? Because from the look wise, looks very similar, right? There are two specific reasons for that. Okay, first, you can see here that NumPy arrays takes considerably less amount of memory than Python list. We will see why. And when you are talking about data analytics, data science and machine learning, you are talking about lots and lots of data, which you need to store in memory or somewhere else for processing. And if that data takes less amount of space, it's a win-win situation. Okay, and that's the reason NumPy is preferred. And the second reason is that NumPy is created by considering mathematical operations in mind. We will also see that in the moment. Let's first understand the memory usage of NumPy array versus Python list. So here I have a NumPy array. Now NumPy array has various members which can give us valuable information. So one member is size, that tells the number of elements in the NumPy array. Another variable is item size, that tells what is the size of individual items in the NumPy array, size in bytes. So if we have these two, we can get the overall size of the NumPy array, which is 20 bytes. Let's create a Python list, similar list, and length is 5. Let's try to understand how much size in terms of byte is being used by this Python list. To get that, I am importing sys, and I am just multiplying length of Python array with sys.getSize of 1. 1 is a number, but in Python everything is an object. So 1 is an object of class int. Okay, and if class int size of 1 is x, class int size of 2, 3, 4, 5 will also be x, and multiply by length, we get 140 bytes. Okay, size of an object is 28. So NumPy 20 list 140 with just 5 elements. You can imagine when you have hundreds and thousands of rows of data, how different it will be. Now with NumPy arrays, further optimizations are also possible because NumPy arrays are having their own data types. The data type is not Python objects. Remember, NumPy arrays are having data types, but these data types are not Python objects. Okay, so if I create a Python var with 1, the type will be class int, as I just spoke about. But in case of NumPy, the data type is int32, very similar to what we get with C language. So the data type of NumPy elements are directly mapped to C language data type. They are int32, int64, int8. Okay, they are not class int. Okay, which means that we can use a data type which is less than 4 byte. For example, in this particular case, I have 1, 2, 3, 4, 5. These elements can be stored in a single byte, character type, or int 8. Okay, single byte integer. I can store up to 127. Okay, so I can provide the data type as a d type parameter while creating NumPy array, and I can say np.int8. I can say int32 or something like that. And if you go ahead and see the size is 5 now. 140 for Python list, 5 for NumPy arrays. Now let's talk about what is the magic behind this reduced size. The magic is NumPy arrays are of homogeneous type. They will be either integer or floating point type or unicode type. They are not like Python list where element can be of any type, right? So in NumPy array, all the elements are homogeneous, which means they are of one type. Okay, so in here, if I create Python array with integer, floating point, string, it will work. Okay, because it's a list type, individual elements will be int type, float type, string type, and so on and so forth. Can we do something similar in NumPy? As I just said that NumPy is a homogeneous array, but still we can do it. This is a valid code in NumPy array, but the data type will be unicode. So NumPy arrays will always be homogeneous, but the data type will be something which can accommodate all type of data that is provided in the NumPy array. If it is integer and floating point, it will be by default float, because integer can come in float but not the other way around. Similarly, this can only be accommodated in Unicode data type. Okay, and we can just calculate these things. And with the Unicode data type, I generally do not calculate. There is some issue with it. It's not necessarily B20, but for weird reason it is coming. And there is no reason to store Unicode data. If you want to do data science, data analytics, machine learning, there is no reason to store Unicode. Of course, when we talk about data frames, we can use that, but it has limited use cases. And we can decide Unicode type also and provide the data type as np.unicode. Okay, same is applicable for multi-dimension array. Okay, we can pass data type, or it will have its own data type with number of rows, number of columns, with total size and individual item size. So it is going to be 40 in this case, but we are not going to talk about multi-dimensional array at this point of time. Now, before we go ahead and talk about mathematical aspects of NumPy array, let's understand some of the functions of NumPy array which we are going to use more often. Okay, so till now we have created NumPy arrays by providing a data. I say np.array and I have provided a list. What if I want to generate a NumPy array with predefined data without providing each and every data individually? And that's what we are going to do most of the time during our calculations. So there are some useful functions. Some of them are empty. Empty means, you understand, it should be creating an empty array, but it is creating with some random values. I don't know why this is the case, but if I create an empty 2D array, it still gives some random value. So empty, you can create single dimension array or multi-dimension array, and it will give you that size array. Okay, and when we are talking about multi-dimension array, there is one thing which is very interesting and important, that is reshape. We are going to talk about reshape in detail in some other video, but what it does is that it changes the dimension of NumPy array, 1D to 2D, 2D to 1D, and even 3D if multiplicity factor matches. Okay, in here I am saying I will create 2D array with 5 rows and 2 columns, but I want to reshape it into 1 column. Row you decide. Okay, so -1 means this part you decide, second part I am telling over here. So you can reshape it. Okay, it's not a problem, but we will talk about reshape in some other videos, or while talking about NumPy we will use reshape most of the time, so you will get to know about it. Another function is zeros, which means that it will create array of predefined size whatever you give in the function, and all of the element will be 0, 2D zeros, and again I can reshape those zeros. Similarly, we have np.ones. 0 creates an array with all elements as 0, 1 will create array with all elements as 1. Okay, now let's talk about arange function. It is very similar to Python range, okay, but it has more options than Python range. So this np.arange 0 to 10, it's very similar to Python range, where it will generate 0 to 9 in a step of 1. Okay, so you can say 0 to 9. And you know what, I can actually define the interval. In here I want to generate element from 0 to 20 with an interval of 0.5, and here are the elements. If I don't give any interval, it will be 1 by default. Okay, and we can reshape it as we are reshaping earlier arrays. Okay, this also we can reshape as different rows and column. If the multiplicity factor matches, if there are 20 elements, you can do 5 into 4, 4 into 5, 10 into 2. Okay, now if you want to fill all the array elements with a single value, you can use fill function. I say fill everything with 10 and arr.fill as 10. Okay, now let's talk about the second reason why people use NumPy array, because of the mathematical operations. NumPy is created for mathematical operations. So let's compare it with list. In this particular line of code, I have created one Python list, one NumPy array. So what will happen if I multiply list by 2? It will duplicate the elements in the list. If I had 1, 2, 3, 4, I will again have 1, 2, 3, 4 and 1, 2, 3, 4. But what will happen if I multiply NumPy array? The elements of the NumPy array will be multiplied by 2. It will be very similar to matrix multiplication. And this is what we do while doing the data science, data analytics and machine learning. It is meant for mathematics. If you are doing multiplication, NumPy arrays knows what is the mathematical rule to multiply these things. Similarly, if I just do list plus list, Python list plus Python list, it will again duplicate. But if I do again NumPy array plus NumPy array, it will add individual elements. Okay, just like matrix addition. But this will not work with string type. List will work, but NumPy array will not work. Okay, in this way, because there is no mathematical rule for multiplying strings. Okay, and that's the reason it is giving an error. So this is what I wanted to talk to you about NumPy in this particular video. I'm going to talk more about NumPy in upcoming videos and many other things in this particular series, where I'm going to talk about Python tools for data science, data analytics and machine learning. Thank you all. Thanks for watching. We will meet again. Until the next time we meet, good day, goodbye. You take care.